have the paper presentation for this session. The title of the paper is Demonstration of Secure Key Management Solution with Use Case in Permissioned Blockchain. The author is Ms. Geetha. Please.
Thank you, sir. Good morning to one and all present here. I am here to present our paper titled Demonstration of Secure Key Management Solution with Use Case in Permission Blockchain, which is co-authored by Ms. Kausalya and it is mentored by Dr. T.R. Reshmi, scientist and as well as the principal investigator of this particular project, UBF at SETS Chennai. And this is funded by MEITI as a consortium project and it has been launched as a Vishwasya National Blockchain Framework 2 days before by MEITI. So the outline of the presentation goes like this. So introduction to need for a HSM or a key management solution in a permissioned blockchain network like a Hyperledger Fabric, background of HLF and the public key crypto standards that we use for integration with the HLF, and the basic operations of a fabric, the permissioned blockchain that need a private key or a PKI infrastructure, the proof of concept for our implementation, the recommendations in integrating the HSM with any distributed applications like blockchain, followed by conclusions and references that has been used for this. So in any PKI infrastructure, the private key is an ownership of any digital asset and it has the control over any digital asset that we placed it. So the compromise of the private key may have an irreversible security losses. So the identity and access management system that we claim to be secure by means of using a PKI infrastructure can be irrelevant when there is a compromise of the private key. So the secure storage solutions or secure key management solutions for the private key like HSMs, encrypted vaults combined with regular or strong encryptions, access control mechanisms are essential to prevent the compromise of the private keys. This particular study investigates the security of PKI entities in an extensive distributed applications like blockchain. It features a prototype that integrates an indigenous CA for a Hyperledger Fabric with a hardware security module, and the demonstration has been done with a secure software module and emulation of a practical HSM. So before we just proceed with the detailed discussion of the integration, we just want to make clear one point that as a part of a national blockchain framework, we had two products that has been delivered. One is an indigenous certificate authority that has been developed for a Hyperledger Fabric, and second one is this particular thing, a secure key management solution for the same fabric. The Hyperledger, which is a permissioned blockchain framework, comes with its own Fabric CA component. So the SETS has replaced the Fabric CA component with an indigenous CA, custom implementation of their own PKI infrastructure in accordance with the blockchain fabric, and we have delivered it as a first deliverable for the national blockchain framework. So the background of Hyperledger or a permissioned blockchain framework. So Hyperledger is widely used to private or a permissioned blockchain framework with a flexibility in application to different varieties like starting from e-healthcare, IoT, and to larger number of applications like supply chain management, land record, health management systems, etc. HLF access to the distributed ledger, which is an immutable component of any blockchain fabric with a valid crypto credentials. That is primarily a public key infrastructure with a public and private key, with every node has been validated and verified to a digital signature component and X.509 certificate. The identity and access management system in HLF is handled by a Fabric CA component which provide a PKI-based crypto credentials and keepers to every nodes that enroll inside your fabric. As a part of a national blockchain service, Fabric CA in the HLF component has been replaced by means of an external PKI-based CA. A secure key management system for HLF using this indigenous certificate authority is our point of study. Before we just move on towards the integration part, we will have a brief introduction about the secure key management option that has been available as in terms of crypto wallets. The crypto wallets are a digital tools that allow us to store private key and do transaction in a secure manner or a client secure manner. So it is a combination of a public address and a private key. So the wallet in general can be classified on basis of three main criteria: a connectivity, nature of physical existence, and control over wallets. The connectivity it is termed as a hot and cold wallets. The wallets that are connected or actively connected towards an internet infrastructure is termed as a hot wallets, and they are flexible to do and everyday transactions. Cold wallets are traditionally an offline wallets, and they are not connected to internet. They are isolated in nature. Cold wallets are claimed to be more secure because of their isolation nature, but they are not flexible for an everyday transaction. Based on the physical status of existence, they may be classified as hardware, software, or paper-based wallets. Hardwares are typical HSMs or the smart tokens or smart cards that we use for a secure key storage. Software-based wallets are a secure key management solution, a hardened key management application that offer a secure key storage in a mobile, or desktop, or computer-like applications. So they yet offer a storage inside your file system, a local host file system, but yet they are secure in nature by means of an AES-128 wrapping or encryption, and yet the keys are stored in an object format. Any access to the private key without the PIN may create a segmentation fault or a dump. And the paper-based wallets are a QR code the QR code or format that store the physical that store the private key. The physical damage may of course tamper your QR code, and yet you will not be able to retrieve your private key. And the last is the control over the wallets. It may be a custodial or non-custodial wallets. When the user who just stores the private key, or an enterprise which stores the private key, when it has a complete control over the key storage as well as the slots, it is what we call termed as non-custodials. A custodial wallet, there was an enterprise which is holding a HSM, and there is a slot that is provided to you with which you can able to store your key, and yet you will not have the control over the entire HSM. There was a controlling authority. So the HSMs may be, this particular custodial wallets may be a HSMs, a hardware-based wallets or a software-based wallets, or sometimes a network or a cloud-based HSMs that may be hosted online. So the public key cryptographic standards, we specifically talk about one standard, which is a PKCS 11 interface, which is also called as crypto key API. So why the crypto key API is that? So PKCS 11 is a tool, or it is or a utility, the cryptographic token interface standard that provides an application programming interfaces for the devices that holds the cryptographic information. So the default HSMs or vendor-specific HSMs comes with an interface that has been developed, which is a PKCS 11 API that has been enabled. The default Fabric CA component inside the Hyperledger Fabric also comes with an option to enable the PKCS 11 binaries, by which the file system storage can be changed to the HSM or the SSM, the secure software module. In the proposed work, the HLF uses an external pluggable CA, which is also a PKI based with its custom implementation of an ACDSA. Hence, to integrate our CA within the HSM or a secure software module, it is necessary to enable a PKCS 11 binary or a PKCS 11 interface in this particular CA. So the PKCS 11 libraries will be modified. They have been modified in order to use the custom CA implementation. The right-hand side part of the code snippet indicates the flow with which you have to touch your PKCS 11 binaries when you are attempting to use a custom implementation of your any cryptographic algorithm, whether it may be a symmetric or an asymmetric cryptographic algorithm. Yet you have to integrate your algorithm into your HSM. So this is the way in which you have to touch your PKCS 11 standard. So the two major operations of a Hyperledger Fabric, which extensively use the private key, are the enrollment process, an initial enrollment process, and a transaction proposal and a signing. The diagrammatic representation or a flow diagram of an enrollment process has been presented at the right-hand side part of this particular slide. The enrollment process needs a CA for generation of a crypto credentials. The private key will be stored inside your HSM vault itself, yet the public key will be retrieved outside the wallet, because there are a lot of verification process that will be happening. And every strike inside a HSM may reduce your efficiency, since blockchain is a distributed application with geographically disseminated nodes across your country, and yet you can't go for a centralized vault that have a lots of it. This may reduce the efficiency. In the same way, after an enrollment has been done, the digital verification, the client application generates a transaction proposals, which includes the details about the transaction, such as a chain code or a smart contract, and it will be submitted to the endorsing peers, nodes inside your Hyperledger, and they use the private key to just verify whether this transaction is valid or not. They will sign, endorsing peers will sign the transaction using the private key, yet the private key will be retrieved from the HSM vault, and the transaction may be added towards, if it is endorsed and it is a committed, it may be ordered as a block inside your blockchain framework. So the two main operations, generating the key pairs inside the HSM, getting your public key out from the HSM, and getting a certificate that CSR generated, certificate signed inside your HSM, and a transaction proposal and signing. In normal PKI infrastructure or an operation, an X.5 means a certificate authority, it is enough to generate a CSR, get your certificate, X.5 certificate signed, and it is a digitally verified certificate. When the certificate is revoked, when there is a CRL, you just again go for your, you generate your keys, again go for a certificate. But the case of blockchain, it is little different. Apart from the certificate signing, the traditional place of certificate authority, it is a nature for a HSM to also support the process of transaction signing and committing. So the proof of concept for this implementation has been done with a secure software module or a software security module. We used an open source implementation of a soft HSM and emulation of a hardware security module. A soft HSM provides all means of cryptographic security for your private key apart from the physical security that is offered by your HSMs. The default network configuration of HLF with two organizations, one ordering service node which is responsible for ordering your transactions inside your block, two peers, one will be an endorsing peer which endorses your transaction and a committing peer which commits whether the transaction is correct or not, and one certificate authority which is an external certificate authority which is provided by SITS. The soft HSM, the CA that we have developed and the Hyperledger Fabric, the CA that has been integrated into a Hyperledger Fabric has been up or hosted as a Docker container service for security purposes and continuous running. So we hosted the CA as a Docker, which is an independent Docker. So to just enable the integration feasibility, we also tried hosting the secure software module, that is a software HSM is integrated with an external CA and it will be run as a separate Docker container. The HLF, the Hyperledger Fabric, which will be loaded as another Docker container. A client who want to enroll may be attached to any one of an organization. An organization will have its own certificate authority attached to an SSL and which will be responsible for generating all the crypto materials and operations. So the integration has been attempted with the soft HSM as a Docker along with its indigenous certificate authority of the SITS. So we just finalized some recommendations based upon a study that we have done. So we just finalized some recommendations for enrolling the hardware security modules. So the HSM is actively for a Hyperledger Fabric or a blockchain-like application. Apart from generating a CSRs and certificates, your HSM has to do a little more job. Of course, the HSM is actively involved in both enrollment and the transaction signing processes. So the performance of the Hyperledger Fabric, a blockchain, the number of transactions that has to be committed per second, maybe in terms of 10,000 in case of a fast fabric or a scaled up fabric. So the performance may vary depending on the firmware or a HSM version that has been used for an integration. When you are developing a custom crypto implementations and you are using an external certificate authority that has to be integrated with your HSM or any software HSM, so the cryptographic standards of your implementation may vary. So we recommend you to modify the PKCS11 binaries or libraries to incorporate your custom digital signature algorithm or your custom public key infrastructure. This overhead, of course, may induce this modification, of course, may induce some overhead in your key generation process, since there was a two-layer of abstraction that you have to cross to generate a key inside your HSM. So this may introduce some overhead. Yet the optimization of CA may yield a better result. So the conclusion, the feasibility of integrating the HSM into the permission blockchain framework such as HLF with the custom implementation of CA has been attempted. The POC of implementation with the software emulation of a HSM has been hosted as a Docker service and it has been tested. So the private keys has been generated and stored inside the SSM and the CA-based crypto operation has been validated inside the SSM. The potential limitation in terms of scalability of slots for HSM for applications like blockchain has to be validated in the when it is hosted as a network service. The complete performance benchmarking and optimization of crypto operations in custom CA based upon the service for which the blockchain is hosted must be accommodated in the future. So these are the references that has been used. The reference of an indigenous CA that has been used for a Hyperledger Fabric is again a presentation that has been used that has been done in a PKI 2023 and it will be available in the proceedings. So thank you. And queries.
I have a question.
Yes, sir.
You know, when you have a overhead, it has an impact on the underlying consensus algorithm, which leads to unfairness. So technically, these things cannot be done in an isolated manner at all. The most important thing is the consensus algorithm in the blockchain platforms. In fact, whenever you try to enhance the performance, it fails because a consensus algorithm will not work like that. And also, it's very important to see it in a totally integrated way, because nowadays the blockchain platforms have more unfairness problems rather than fairness.
Thank you, sir. Actually, we can understand that there was a large overhead that may happen at the consensus part of an algorithm, and we want to be, as I said in the starting of a presentation, as a part of the deliverable, we are concentrating on a certificate authority and the secure software module that we have to deliver for a national blockchain service. And the integration has been attempted, but the performance benchmarking as a blockchain as a service is still under study. We know this may create some overhead when there is a centralized HSM that has been used, that must be used for a consensus mechanism of transaction. So we understand that, but it is still under progress and as under study, sir. Any other questions? Yes.
See, it's a very good presentation and very good work initiated by SET's team. My only query is that why do you want to modify the PKC 11 libraries? It has some standard format, and it has to be when you do an internal CA operational activity or custom designing CA for Hyperledger Fabric. So two things, the drawback is, one is the overhead.
Yes, sir.
And the more modification what you're planning to have executed in the PKS 11 standard, what are the drawbacks you have been facing it by overhead which you have been facing it for the computation time?
So the first thing is it induces some. We have to agree that it induces some overhead. The benchmarking or an optimization is an
If
understudy.
you do some modification overhead, it's okay. But what are things you are going to achieve out of that overhead?
So the first one is we just started our emulation with a secure software module, a soft HSM, which uses an OpenSSL, which has two options: to use a bolt-on SSL or an OpenSSL based crypto implementations. And your HSM or a SSM will just connect you to an external word or any application. If it is not a traditionally CA, it will connect you to any external application only by means of an interface, a cryptographic standard, that is a PKCS11 tool. So the PKCS11 tool or an OpenSSL itself, they have a direct communication. They can able to understand it. But we are not using an OpenSSL operations for a key generation or a bolt-on SSL operations for a key generation. So we have a plugin interface. So we have our own methodology of key generation outside. So the way
this overall you are talking about the increasing the key generation process
and the CSR and the certificate generation activities, sir. As a whole, only the X point, we are not talking about the use of private key for a transaction proposal and signing. That is a different activity that don't have any touch with an OpenSSL level operations. So the first phase of getting your digital identity signed from our CA. So that requires a modification of the PKCS11 binaries in accordance with our flow. We have our implementation that has been FIPS validated. So we have an option to add our custom implementation into an OpenSSL library such that PKCS11 can able to understand our implementation. So we have our next, in the next session, we have paper
provisioning you are introducing in the hyper HLF so that this PKCS11 has to be modified.
Sir, when you use a Fabric CA, don't have to be modified. The Fabric CA has set up in such a way that it understands the OpenSSL and PKCS11 operations. So we just replaced the Fabric CA. That is, we made it as a default disable it, and we just enabled an external pluggable CA for a Hyperledger Fabric. So it just wants us to modify that such that we can able to accommodate our CA seamlessly into the HLF operations.
So it means you are linking towards the internal CA operation only for the PKCS11 standard, right?
Yes, sir.
So that is the only achievement you are planning to do with HLF, right?
Yeah, so make sure that your hyperledgers understand your external CA, but in a standard format, the PKCS11 format. So
Okay.
that must be a standard. So suppose if the external CA has been replaced and some other CA is also placed, there is no problem. So we just modify your PKCS11 library in a way that we have given us. So you can enable your you can enable your certificate authority into your blockchain.
Okay. Okay. Thank you.
Any other queries? Yeah. Thank you, and thank you for the opportunity.